So, well, this is the beginning of the discussion. We have Studio Divinity. I like the name.
Yay.
We have Studio Divinity here to talk about the things, experience, what we feel about the game we developed for this semester. So, just a brief introduction regarding the game. We developed a first-person adventure game that you're pretty much blind throughout the entire environment. You will need to use shaders and other functions to help you escape from the monsters and find a way out. Um, we have our game trailer and also the run-through video on the slides. Check on YouTube for more details. Today we're going to talk about, going to review the things we did good and review the things that we think that can be improved and maybe some of the future ideas that can be used in this and also what we learned from this experience. So let's get started. So let's start with Eselina. What are the things you think that we did really good in this case?
I think just getting a head start on our game, our concepts in the beginning, like in the pre-production phase, I think was really good for us because we, settled down on a concept. We agreed on who's going to do what, and then I think just we had a very good discussion in the beginning. So we had a clear idea of what direction we're going to go in, what our master plan is going to be. I think that went great. And also, I think we were able to do really good in the last week. I mean, I think we were expecting to have 2 more weeks when we had one.
Sure, yes.
And I think that crunch down went like pretty reasonable for us.
Yep. All right, that's pretty cool. What do you think, David?
I think we managed to put together quite a well-rounded game that doesn't have any glaring gaps. And I think it was partially due to the fact that we laid out our plan in such a way that we had corners to cut and things to scale back in case we did not have enough room, which ended up happening with the smell system, which ultimately was not necessary to complete the experience. And we got on top of the schedule early on, and I think we stayed in touch and kept updating our work throughout the semester instead of just crunching everything at the end. So ultimately we had quite a comfortable pace, and ended up bringing everything together without much of a stress, which I think is also very valuable, besides just the product that we created. And we're still left with a lot of areas for potential future exploration or expansion. So we can sign that off as the future work section they have in papers. It's like somebody else somewhere on a distant planet can maybe one day come in and do this thing and see where it takes them.
That's very good to hear.
I mean, I hope it's not just me. You also share my my impression that it wasn't incredible crunch that just ground us down.
I also agree with the part about setting a core goal and then add on stuff. That was actually very smart for us to do. What about you, Dichuan? What are your thoughts about what went well?
Yeah, I agree with the core goal part. I think we actually nailed that on core goal at the very beginning, and we actually managed to accomplish it. Like the levels, the shaders, and also the AIs. I think those are all combining together really well. We did some really good planning. We managed to work throughout the entire semester. We met our work time requirements and got everything together. Looking really decent. I think I was a little worried at the very beginning that this might be a really high-end goal because this really sounds like a studio level project, and it might be a little hard to accomplish with 3 people that are currently grad students. That they only have a limited amount of time and also they have other work to do. But I'm really glad to see the final outcome. Like by the time I actually finished the build, I was like, wow, this thing actually looks really awesome. And I do wish, if possible, to work on this project even more, to add more elements that makes it more like an adventure game instead of just a game demo. So I'm really proud of the every single effort what we put in there. Regarding what are some of the like? I'm trying to think what are some of the things during the development process that I think is good. We communicated really good. All members, including Austin and Assad, they replied really fast. Everything is getting updated. Yeah, this actually feels like an actual studio. I like it. I like this working environment.
Hi, Austin.
Oh hey.
Hello.
Oh hey.
I
What's
thought
up?
you guys did a marvelous job.
Thank you. Thank you.
Do you also want to share your thoughts about what you
Yeah.
liked about the project?
I
the
really like
process?
the concept of your guys' project. I like the visuals and how it turned out in the end. I know I saw a few of your screenshots and it looked really nice.
Mm-hmm.
But yeah, I thought you guys did excellent.
Thank you. Did you get a chance to check out the video?
Oh no, I didn't yet.
Oh,
I'll look at that afterwards.
yeah. There's a 6-minute full gameplay video of the final build. So if you want to check that out, go
Oh
for
yeah,
it.
for sure.
Yeah.
So like I think we should also talk about how happy are each of us with the final project and like what we might want to like what we want more from it.
Some of the future work goes.
Yeah. So we can start with
Do I want to lead? Sure. Okay. As I mentioned, I like the environment. I like how everyone's communicating. I like how we're putting stuff together. Future work. Because I know this. If we continue to work on this project, this thing is going to be really great. From all the different, aspects of game elements, there's a lot of space for improvement. If you look at those 3 AAA title games, for either AI wise, the shader wise, they've done an excellent job on fine tuning it, optimizing it. I think for AIs, this was on my part. We can definitely make it more functional. And since this is the very first time I'm using AI in Unreal, I haven't figured out the full functionality of behavior trees, Blackboard. I wish my monster can be smarter and do more things that I wanted to do as a developer. Um, and also for shaders and levels, I feel like if we have more time into um, applying more types of materials, I think this level can be really high level, and this will definitely be a sellable game from my side. So I'm just wishing if there's another like schedule on working on this, I'll be willing to do it. That's my take.
Yeah, I feel like due to some limitations, we actually brought the shader and the level design together relatively late through the development.
Mm-hmm.
And like once they were combined, there are a few things that like from an art direction perspective I would have like done differently.
Mm-hmm.
Especially since we're using translucent shading. This like exposes the back faces of a lot of objects. So this like if we had like a dedicated team of more than 3 people to work on this, we might want to like design our geometry and meshes around this and lean more heavily into these mechanics because like right now we've only scratched the surface of what's possible with this system, like seeing through walls and uh, kind of like designing puzzles and navigation problems around this, as well as maybe like deepening the AI interactions in this environment. And potentially even like augmenting the shading to allow us to do different sort of effects, not just because we have alpha mapping and textures in AR and in AR in the in the virtual space, but the we can utilize all sorts of like other features of shaders like bump maps and so on, which were left out in this version. I mean, it looks very convincing so far already, but right now we're kind of very heavily leaning into the colors of the sounds that we're emitting. So maybe, so it kind of like ends up like if something's made out of stone, like all the ripples coming from it are going to be stone colored, and it kind of like gives it a uniform look. So with some sort of like masking or custom asset design, we could achieve more more granular sort of visual presentation.
Mm-hmm.
And also, like, in a lot of places when we have the level where it's like floor and there's a wall, but you can still see the floor like going through, like behind the wall, because it's like a single mesh on the ground and it gets exposed through the shader. So there's like a lot of small like tweaks, but like overall, I think it came together really nicely, and it sells a lot of the geometry in the level, especially with the complex meshes, when you can like see all the intricacies and nooks and crannies in the models.
Yeah. I like it that we have, I mean, as a build that we made in the time that we had, I think it's awesome that we have like a working game with 5 levels and 8 different monster AIs. I think that's awesome. But I would definitely love the chance to fine tune things. Like, we definitely could have spent a lot more time on the sounds. Like, I would have loved to have like little things in the environment with like particle systems where, there's like leaves falling, or maybe there's a pipe that hisses in one of the zones and stuff like that. Like there could, if you have like a dedicated sound team, since like just between the 3 of us in the time we had, we couldn't have done that. But like tuning stuff, adding like a intro voiceover and some like cool monster text and stuff like that, I think would have been really cool to see. But yeah, I think that like I'm happy with what we have in the time that we did. And given the chance, I would love to play around with the project more and just have like that polish that I think we're all kind of craving.
Certainly, I almost feel like it's when you finish a really good game and then like you get the editing tools and you're like eager to build more levels for this and see how far you can like push the engine. And so I feel like we're in like a position where we have created the awesome engine, and now we just want to like see more levels and more content.
Mm-hmm. Yeah. I feel the same way. All right, so that's the part for future working improvements. I think one last question is, what are the things you guys feel like you learned the most from this entire experience? It could be game developing techniques. It could be, I don't know, ways of socializing and cooperations. It could be anytime like you feel like I never had this emotion before, now I have it. I don't know, could be anything. Let's start with David this time.
All right. Well, I think I've learned like one of the most kind of like one of my kind of biggest takeaways from this is that I would like to have like focused on getting like a minimum viable kind of prototype out for the shader sooner. Like looking back at how our development process went, I really think that like I'm kind of like I like to take things and create like a nice modular system that is very universal, and like I do it once and then it's like done and like people can take that on. But yeah, I feel like I've kind of like taken that on like for too long, and like we in the end we found out that like it wasn't like the game performs well, but like we're running in some FPS thresholds, and we had to look into the culling to optimize the game.
Mm-hmm.
And I feel like there are like technical like when you're learning like a new tool, like for me Unreal shading was a relatively new topic to explore,
Mm.
and I felt that maybe I should have like allowed myself to like stress test the engine and like kind of like be more like have more foresight and like try to find like fail faster sort of mentality. I think would be useful in the technical department, where like we try to push it to the edge early and it's okay, like we need to like find optimization techniques or like some different kind of way to encode this sort of data structure that we had going on there. So that's kind of like my one pet peeve with this, which I would like to like if I could go back, I would like spend my time differently on it. But yeah, besides that, like I really enjoyed like working on a team that actually like contributed equally. I always felt like I wasn't doing that much work compared to you guys, so
No.
I was like, you've done amazing work on the level designs and all the asset work. So I was just like, after so many projects I basically did on my own, it was a pleasant experience, kind of like sharing a project with some people who are equally interested in it as me. So thank you.
Yep. Thank you as well. All right, Alina, what's your take?
Well, my learning experience. So doing like an entire game in a team when we were working remotely was interesting. I think it was like I feel like we started off like at a very high pace, and then in the middle it was just sort of like, life happens. And I think one of the things I learned was that um, scheduling does not always go as you exactly expect it to, and you need to schedule in time to like also account for other things in life when you're not always going to be dedicated to working on the specific goal or project that you're doing.
Yes.
And also I actually learned a lot about game design. When I was starting the level design, I went over so many like documents and web novels. I don't know what they're called exactly, but I found like a series. So um, I learned a lot about level design, and I also learned that building a level from scratch um, it takes a lot more time than you expect it to, because you have to fiddle around with the landscape and the foliage, and you never get as much detail as you really want to. Um, so that's something that I learned, and something that I wish was done differently is probably I would have liked to have spent more time just working on the audio, because that's something I initially planned to do, and then I got like really caught up in working on the levels. So I would have definitely scheduled it a little bit differently. Um, and yeah, I mean, I think it was overall like a good experience. And one of my first thoughts when I got paired up with you guys was that, oh, like they're really good at what they do. So, um, I don't have to worry about, the AI being like, lagging anything or the shader lacking anything. So it's like cool. Um, but yeah, it was like great experience all in all.
It's very cool to hear. Okay, my part. I think I learned really much. Um, this is probably the time I actually learned the most. Um, that is different from the previous experiences. I've done a lot of like game dev scene classes. I think first started in 2017 when I first started to take the game class. We've been through 2D RPGs, we've been through 2D strategy board games, we've been through 3D RNG testings, and now this. This is actually one of the, I think, the most formal, although it's still a school project, but this is a really um, most completed game that I think I took part in developing. Learned a lot about AI because, as mentioned before, this is the first time doing this. I started zero. I need to learn what a behavior tree is. I need to learn what Blackboard does. I also need to start coding blueprints within behavior trees to make sure things are working. To be honest, I think I spent 80% of the time fine-tuning AIs, just completely closing levels, opening up levels, and see if the AI can actually detect myself or the stuff I throw or my sound or whatsoever. Is it getting blocked? Is it moving? Is it working as I expected? 80% of the time just opening up level, closing levels, doing so on. And I think I wasted like half of those time doing the same exact thing, although I know the result is gonna be okay, this is not definitely not gonna work. But eventually I did figure out stuff. I know AI, what are the conditions for AIs to work, and I'm glad to have all the monsters working as I expected. And this gives me a really good idea of doing logic design. Because logic is really important in AI. I need to consider in what situation this AI does what and what order do I want that thing to happen. Excuse me. So I think logic design is really important in this case because AI does not work with like it's not like players. Players, you can control players like whatever you want. You just think about something and you make an action and the player does it. AI does not. AI has to follow some sort of rules. Although that rules can be determined by themselves, there still needs to be a beginning. Like you need to teach them or tell them what are the things you need to do in certain cases. And besides game development part, this drives me into more logical thinking in real life actually, because I keep on thinking about logics. In real life, and now I realize that some things cannot be done emotionally. I have to think about the reasons and how would other people react, how would something happen, and what are the results if I make this kind of selection. It's like designing AI. I also have to design my real life logically. So this gives me more hints on doing that. I think this is a really weird takeaway, but it actually helps me in living in real life as well. So I really enjoy the experience. I really appreciate it. Other things, I also enjoy being teammates with you too. It's a really good experience working with the team, also remotely. I think this is one of the since we're starting this full semester, I think this is the actually longest time working with other teammates. So this is a really cool experience. I really appreciate that, and that's my takeaway.
Thank you.
Mm-hmm.
Yeah, I want to just add to that last comment that I also agree with it, because usually in the way that these classes are structured, you'll spend like more than half the semester just learning basics, and then you get like a few weeks to do an entire project. So I love the fact that this was structured in a way where we just started right off in the beginning of the semester, and we had plenty of time to think about things, to organize things, and build and actually learn how to do things as an real studio, as a real production. Like, this is our game.
Yeah. Okay, I think that's pretty much it we need for that commentary. Anything else you guys want to add up?
I know there's supposed to be a section about like the producers. So are you gonna do that in your solo video?
I think. Well, I'm not gonna do that in the game dev video. I'm gonna do that in the presentation. I'm just gonna talk about that because there's just some of the positive and negative things I think overall for the team. But I'm just gonna present it in the presentation.
Okay.
This one I don't think should be included in the game dev.
Yeah. All right.
All right. If there's nothing else to add on, I'll just stop the recording for now. This is it. Thank you guys so much for listening for the entire discussion part. We'll now get into the video for the individual developer comments.
Hi, my name is Lena Uslam, and I'm here to talk about my contribution to the game here. So I work mostly on the level design, level creation, and also coming up with the puzzles for the monster types that we came up with in our initial pre-production phase. So I designed the puzzles and the levels, and I put them together in Unreal. So I worked mostly without the shader. This is what the levels look like without the shader applied to it. So before integration, before we brought everything together, you can tell that the lighting wasn't really worked on a lot. But yeah, I brought together a bunch of assets, and this is what I built for the first area, which is the tutorial area where the player spawns and gets familiar with the mechanics and how the game's actually working. So before I started building this, I actually sketched it out a little bit. My very first sketch was an overall sketch of the level design for all of them combined, and it doesn't look great, but this is what it was. The idea was about like how the player would essentially navigate from the first to the last level, and what each puzzle would be like, what kind of layout format we want. So this was like a very rough go at it, and here is just a list of the puzzle ideas that we came up with. We actually ended up cutting one or two of them to make the game more manageable, to make the creation more easy in the time that we had, so that the project could reach its the core goals that we wanted it to. So yeah, then I started working on individual level sketches. So this is what the top-down view of the first level that I just showed you, the village forest area that leads back into the caves. This is what the level design sketch looks like, and this is what the level looks like. Sketching it out really helped with the creation, obviously. I learned that it's really important to do that, and that putting stuff together, building it up, actually takes a lot more time than you'd expect it to. So the player transitions, so we ended up separating the levels in Unreal just because it made it more manageable to create nav meshes, and for Dijon to implement the AIs and stuff. So I ended up separating the levels in different scenes in Unreal. So the idea is that the player goes into the cave under some water here, and then comes out into this cave where he encounters the first monster, which is the charging monster that just breaks down all these walls. So we have to sort of guide it to breaking down this particular wall. Oh, there we go. And then the player kind of navigates past that. I'm just gonna, oops, my bad. So yeah, after knocking down that wall, the monster collapses and the player navigates forward into this little extended cave and finds these stairs to go up, and those lead up to the mine level. So in the mine level, the player spawns somewhere around here, where, you know, the stairs are graded now. But yeah, the player spawns here, and this level looks really weird without the shader, especially considering it's supposed to be a closed area, so the lighting isn't built at all. But this is what the general layout is. And there's a couple of tunnels and with mine carts and levers that the player is supposed to interact with in the right order to be able to escape. So the puzzle for this area is that the player pulls the levers in the right order while dodging the monster to be able to escape. And initially in the design, I had 6 levers, but just to make it more manageable, more easy to actually navigate through the level, I cut down 2 of the tunnels, so it's just 4. And for a game of this scope, 4 works pretty good. And just for reference, just for contrast, here's a little idea of what the level looks like with the shader applied. And for that, I'm just gonna open up the gameplay. There we go. So here's what the first area looks like with the houses and trees. It looks really cool with the shader. I think David did an amazing job with it. And here's like the charging level with the monsters just in the cave destroying everything. And then the mine where you can like see the levers and interact with them and then escape in a cart. So I had trouble finding a good asset for the cart actually. So Austin built us this really cool cart and textured it and everything. So yeah, I think it turned out really, really well. He did a great job with that. And yeah, so after the mine level is this little industrial zone that the tracks lead out onto, and the idea is that the player sort of comes out from these train tracks, spawns into this industrial zone where he walks around and goes into this little building where he encounters the behemoth monster, which just essentially destroys everything. So it's just a circular path within this building where the player has a chance to interact with a bunch of interesting materials and textures, I think, and just sort of tries not to die under the rubble and escape. So we have, again, for reference, I think the industrial area actually looks really cool with the shader. So yeah, we have like a little building and the monster that we're trying to escape here. And I love that the difference in the colors and everything. So yeah, that is my contribution to this game. I worked a lot on the level design, level creation, building it up, designing the puzzles, and it was a great experience working with my team. I was really happy to be paired with Deshawn and David. I was very confident. I knew they were really good at what they do, so I was very confident that the blueprints and shaders would turn out great as they did. Yeah. Thank you.
Alright, hi. So my name is David, and my task on this project was to create this ripple shader, which we use to visualize the sound waves in our game called Here. So essentially, you're playing as a blind monster, and the only way you can navigate your environment is through seeing sound waves ripple through the environment. And this posed a unique challenge because we had to figure out how to present this sort of information in an interesting way with essentially a blank screen most of the time. And learning from past games that have tried a similar concept, we discovered that very often the issue is sensory overload. If we make the ripples travel too quickly, too abruptly, it's going to be nauseating and it's going to confuse the players. So my task was to come up with a solution which we can easily integrate into our environment here. And one of my goals for this project was also to make it kind of slot in so that even our level designers could work around this system. So the way it works is, as you can observe here in the environment, we have these ripple emitters, and the emitter carries all the necessary information to make this visual effect show up. Then this orange component here is a ripple holder. It's just a empty component that facilitates some functions in the scene, and the important bit here is the ripple painter actor, right? So the painter actor with the paintbrush here is very important because it encodes all the ripples visible in the scene into a data texture, which we fit into the shader for the actual surfaces of the level afterwards. Alright, so I can go ahead and show you the ripple texture around here. Alright, so this is how the texture looks like. It's a 64 by 5 pixels. I'm not sure to which extent Unreal Engine rounds off to the nearest power of 2. It might be more optimal to have a 64 by 8. But regardless, so in here, the first 4 rows are various things about the settings of the emitters. So for instance, location, the pattern type, and so on. And then at the bottom, there's a palette for the different types of ripples. So like each of the colors represents different type of material. Right, and if I zoom in on this one, so the component here for the painter lets us see I'm not in play mode, I'm in editor, but I can activate it and have it update in the game, in the editor itself, so that if I'm building the level, I can kind of visualize the reach of these sources, and also I can switch into not raw view but builder mode, and builder mode enables us to view geometry. So one of the big issues in the original first build we had was that, simply put, without the ripples, I could not see the geometry of the level at all. So this fixes that. Kind of makes this tool more usable to the rest of the team. If I switch back, you can see that the animations persist even when I switch off the painter, and that's because the shimmer is done through the shader itself, right? So taking a closer look at this ripple here, I'm going to demonstrate all the possible settings. Right, I'm going to enable painting so we can see them reflected in real time. And here, so the inner radius, so the inner radius is the thickness of the ring that's rippling out. The outer radius is the entire outer reach of the effect. And then the fade radius, it's not apparent from here, but like the fade radius, you know, if I max out the outer radius and I set fade to 0, you can see there's an abrupt end. You know, when I fade it, it kind of becomes a little blurrier. This is not the right curve to demonstrate that effect. You know, so here we can select different colors for the surface. The age is going to influence the speed at which the effect plays. And afterburn is an interesting effect, which I actually have showcased here. Right, so these two ripples have the same setting, and the only difference is that this one has afterburn set to 50, and this one has afterburn set to 0. Right, so essentially afterburn means we play out the animation of the effect very quickly, and then you know, we let it burn afterwards to create this like slow fade out, right? So you can still make out the geometry of the level as it slowly fades, right? Whereas this one, you know, if I just slow down the ripple, it doesn't really look well like a resonating sound wave, right? This one is like, well, I ripple and then I leave behind this like fading trace, right? It's very hard to show on a static ripple though. And you know, the final settings are chaos, right? So chaos influence, I can set it to like 50, I can set it to 200. It's the amount of offset done to the distance. And you know, I can control the speed of this effect. And I can also ramp it up to create chaotic noise. And the final setting is quite significant, so let me scale down the effects. Let's leave like a slight shimmer. And we have different curves we can apply to the effect. Right, so as I go through these, you can see different styles. And these are actually not arbitrary, but they're in full control of the team working on the game. So if I bring over this curve asset from an atlas, and actually I have to choose the other curves over here. So if I choose these, oh, let me go back here. So right now I'm using curve number 1, which should be red. And you can see that if I modify the curve, it modulates, so I have to make sure that the curve begins below 0, so it doesn't illuminate the rest of the environment. Then I can ramp up the curve. I can let it fade into a non-zero value. And if I indent the curve here by adding key points, hold on, I think it's snapping on me. Okay. So if I indent the curve now, we can see the indentation reflect immediately in the shader, which is like another piece of very useful kind of tuning that the level designers can make on the ripple shader, you know, to fit their environment and specific needs of particular sound sources, right? And of course I can do different types of playback. So this is the yo-yo, so that's like when it ripples out in and out. The regular is just one way, so it fades out. And there's no fade out time, so if I up the fade out time, so now it ripples and slowly fades at 0.5. If I do it at 0.2, it's going to be visible for longer and then fade out. Right, so this is basically how you design these ripples. And I'll just enable sound for a bit. So you can bask in all the glory of this annoying soundscape that we use for testing. Like in an actual game, it wouldn't be so obnoxious. Alright, so very simply, just an overview of the painter component, right? So it goes, makes all the settings for the shader, and now these parts we render into the texture, and these are just some components that help us encode the pixel coordinates for all the data that we have there. Okay, so that's the kind of coding part of things, and now let's move over into the shader. So the main shader consists of these three chunks. So it's an unlit shader with some emission and translucency. So that means, you know, if I come here, I can see the front and back face of these objects, which is quite taxing on the performance. But you know, here is the usual kind of sort of shading, which then you would expect from a normal material. We can toggle between world and object-based coordinate system. So world is perfect when you have some mesh that is stretched. Use the world coordinates for UVs. Quite convenient, you know, if you want something to seamlessly blend together. Here it's multiplied with the mask. And the mask, or the ripples, are the important part. So it doesn't look like much, it's 6 blocks, but each of these blocks, if I take a look inside, consists of 16 ripple blocks on the inside. So in total, we can handle 64 sources of rippling, each represented by a single column in the data texture. All right, and if I go into one of these blocks, one of these 64, this is how it looks on the inside. So quite a hefty shader code block here. And what we have here is, so this section here in the beginning is responsible for decoding all the encoded data from the painter. So outer, inner radius, fade, type, chaos factor, chaos speed, age, etc. The type is sent back here to decode from the texture the appropriate color for that particular material. You know, here from the location, we calculate how far we are from the center of the emitter. We divide by 1000 to fit into the color range from 0 to 1. And then like we multiply back by 1000 to get the actual world coordinate sizes. Over here, you know, classic trigonometry. If we wanted to be a little more efficient, we could get rid of the square root here and just work in power of 2 instead. Here is so then that gives us the raw distance of each pixel that we're shading from the individual emitter. We feed that into the chaos block where we kind of play around with the distance before we pass it on to the other sections. All right, and then we have a lot of smaller components here. So the fade time is pretty straightforward. You know, as time passes, if it crosses the fade out boundary, we start fading the intensity of the ripple effect. Inner, outer fade radius. So this is the part where we take care of, you know, like, so if my distance is beyond a certain point, I start falling off. And also with time, here with time, the ripples, inner and outer radius, span out, and these if statements branch the different sorts of behavior. So I can have playback time fed in here, and then like if my playback is 3, no, if my playback is equal to the 3 or 2, I do the yo-yo or the repeated ripple. Oh, excuse me, the static ripple. Then we also multiply that by the fading distance mask. So that means when I'm outside of the outer radius, I'm in the fade zone, so I kind of blend it in. And here is the section that, you know, from the raw distance that we calculated here ran through chaos. We also run it through the curves, right? So if that's when I convert that from just a raw distance into whatever shape I've. Do I have them on hand somewhere? All right, so that's kind of my distance. My inner distance is here, my outer distance is here, and all the way in between, I have this curve behavior. And if I go past these, it kind of like just uses the latest value from those. All right, and then, you know, all these individual pieces, the beauty of it is you can just multiply them together. Like, you know, like all the fading effects and so on, and they like this, it combines the effects, and then, you know, when we leave this block, we just add all those influences to get the total kind of ripple color / amount of influence, which then gets, you know, if we're in the builder mode, we just add some flat amount of color so that we can see what's going on in the scene. And that's pretty much it. In effect, there's some bottlenecking because obviously every single pixel that we're seeing with no culling enabled because it's translucent has to calculate all of the 64 emitters. So that's quite prohibitive. And in fact, I tried to implement some custom code here to have forceful hard ifs. So it means it's going to skip over testing everything past 16 if, you know, I know from a uniform variable that there is not going to be 16 ripples right now in the scene. You know, this places a little bit of responsibility on the level designers, so they have to use the ripples sparingly and reuse the cyclic ripples, and overall, you know, try not to overwhelm the scene. These short temporary ripples for like footsteps and other effects like that are quite manageable because they usually fade within a second. So even if you run, you won't spawn more than a fixed amount of them. Alright, that's everything I wanted to illustrate for this ripple demo. I appreciate your attention, and I hope you found it educational and useful. Thank you for your time.
Alright, hello everyone, my name is Tishun. So for this part of the game dev video, I'm going to go through the AI that we did. So I am mainly in charge of the bots, the AI production for all of the monsters. In this game, we do have 5 different monsters. We will start with the charge enemy in the cave level, and then in the mine level, we'll be encountering into the mine monster and also the behemoth. After that, in the industrial zone, you'll need to escape from a... I'm sorry. Well, it's actually the mine monster and the spiders in the mine level, and then we'll need to escape from the behemoth in the industrial level, and then finally we'll need to escape the temple by avoiding the final boss. During the development, this is my first time doing AIs in Unreal. Despite the fact that I actually been working with Unreal for so many years, this is the very first time I get into this. I started to learn how to use a behavior tree. I started to learn how to do blackboards for all these different monsters, and then along with the AI part, I also need to get done with the animation blueprints, collision events, overlapping events, and all the different mechanics that each individual monsters has. So, well, I'm really glad that we actually got it done throughout the entire semester, because this is, I think, one of the biggest part for unboxing the black box for the entire game. And I think this is also a part of our core goal. So I'm really glad to get that out, and I really appreciate people who helped me throughout the way. So let's get started. Let's get started with one of the easiest behavior tree that we have actually done. So for the base behavior tree, we started with something that can just roam around within the navigation mesh, and then whenever it detects a player, it just moves towards them. So I'll take the I should probably use the final boss, shouldn't I? Yeah, I should use the final boss, I think. So the final boss this is like a really simple behavior tree that I created over here. So this is just a really simple roam around enemy. Whenever it detects you, it'll just walk towards you. So the behavior tree works like you have a selector. By default, it's gonna run on something that does not have a condition. Say you have a roam function over here, and then you do a move to, and then you wait. So basically, what the monster is doing here is it just walks around, changes to a different direction after every 2 seconds. Whenever it detects you, it'll move towards the target. And by target, I have it set in the blueprint as the, well, this is the character. Yeah, here we go. In the AI controller, I've set the target into player index 0, which is the default first-person character. So for each individual boss, you need to have a behavior tree like this. Well, not this one, this. You need to have an individual behavior tree along with the blackboard. That blackboard is a place that stores all of the individual keys, and also you'll need to have a character with a movement component with everything, and also meshes. And then you also need a controller. I think the controller and the behavior tree are two most important parts when it comes to constructing a boss with AI functions. And also within the control tree, we had 2 individual sensors, I say in this case. Well, sensing components, based on what it says in Unreal. The pawn sensing is used for sights. So whenever it sees something, it will get through the pawn sensing. See over here, we have on see pawn, and then it does this and that. And there's also the AR perception. This is used for hearing. I don't think the default function in pawn sensing for hearing works. Maybe it just didn't figure out a way, but I feel like using AR perception is better for the hearing part. So whenever it hears the sound, it does specific actions if the monster has one. For example, for mine, we have, if it hears the sound of the rock, it will flee away. For charge enemy, if it hears the sound of the rock, it will rush towards the rock. Oh, well, run towards the rock. All these different kinds of functions. But yeah, these are the 2 sensing components we have, and we implemented these for all the different monsters. So this is the final boss controller. As you can see, whenever it detects a player, if it's not crouching, it does this and that. If it's crouching, it doesn't do anything. So the final boss can basically be avoided by not letting the boss see you. You can just hide behind an object, someplace that is high enough to hide your entire body. So in that case, the boss will not perceive you. Really simple mechanic to work on, but it actually takes a lot of time to accomplish. So that is one of the basics. And now the next one I want to talk about is the charge enemy. Besides the basic functions we had, like the rotation and walk around, we had 2 different functions that includes a charge function. So basically what it does is it actually charges towards the space behind you when it detects you. In that case, we developed a blueprint over here. I actually didn't realize that you can customize blueprint tasks until the first half of the semester. So what it does is you can go into this new task over here and you create a new blueprint task. It's called BT task, blueprint base. And after I realized this is possible, this made my life so much easier because I can just literally code everything within the blueprint and I just put it in here instead of using the default task, because there's really a limited amount of tasks over here. So if you see tasks, there's only this much. There's only this much you can use. And some of them are even the blueprint tasks I created afterwards. So initially there isn't really that much thing you can do within the behavior tree if you don't create your own tasks. So these things are really useful. And also there are decorators and services that you can also use to control the flow or create certain conditions for the selector or the sequence and stuff, which is really convenient. So what I did is I asked the charge enemy to calculate location first, and then it rotates to face a specific entry. So after it calculates the location, it will charge towards you, and also I'll make it stop charging and then let it wait for a few seconds to give it a cooldown. And then the second best mechanics I did in this is that if I throw a rock at him, he will run towards that place where the rock hits. And it also breaks, we're using this mechanics to break walls in the level so that players can actually reach to the destination point. So in order to make that work, I did several testings and realized that this boss has to be turned towards the rock in order to make this thing work. So I think that's how the AI perception mechanics works in Unreal. If it's not detecting any objects in sight, the node just doesn't execute. I think that's what it does because I encountered into several errors and bugs when I was testing this, and it turns out that I need to set up a rotation towards or where the rock hits, and then you can actually charge towards it. That's basically it. So that's for the charging monster. And the other two monsters I want to talk about is the mine monster. So the mine monster is something a little bit different. When you do not make a sound, like you crouch and hit your footsteps, this thing walks with a sound. And if you make a sound, let's say you didn't crouch and just walks normally while making footstep sounds, this thing turns into silence. So in that case, players are really hard to tell, well, really hard to find where the monster is unless you use your rocket spawn emitter and you see it somewhere nearby. Otherwise, there's no way for telling where the monster is. So this is mechanics that players need to find out themselves. In the behavior tree, basically what I did is a simple blueprint task. Let's say if you detect a sound, then you're gonna turn the silence thing off. So yeah, over here you can see if it hears a sound, we'll set the sound mix class override into volume 0. So in that case, it won't make any actual sounds. If it doesn't detect any sound anymore, we'll just make that volume back to normal by using this blueprint over here. We set the volume back to 0.5. We think 1 is too loud. So that's how the mine monster works. And also the mine monster flees away from the rock. So basically what we did is we made a turn, but using getting full refactor, we get a location that is supposed to walk back towards. We made a turn that way and just flees back. So in this case, when players sense the monster are coming at them, they can just simply throw a rock under their feet and scare the monster away. This thing also works for the other type of monster, which is the spider. The spider also can be scared away because if the player touches the spider, they will be poisoned and will be frozen around. Actually, they will be stunned for 2 seconds at the level. And also we have the behemoth blueprint that is actually really similar to the charging monster, but what we did is we set it up a rampage animation. So whenever it charges the player, the run animation changes into more like a rampage style. To do that, we just set it up blueprint. Whenever it detects the player, it gets into rampage mode, and we set this value from our game base. And then we made a specific modification in the animation blueprint. So we did a check rampage function over here. Whenever it's rampage, we set it to rampage, and also in the same machine, in the rampage, we have a specific animation for this. This is the charging animation, and also for a normal walk, it's just going to be something like, if you drag this thing over here, can I? Yeah, it just goes forward. And after making all of the 8 different monster AIs, I also need to make sure they're working in individual levels. So after I receive the levels from Alina, I do need to put in navigation meshes and also put in the monster to test it out, because sometimes the collision and also the navigation mesh with the environment might be a little too complex for the AI to detect. I had to make sure everything works. One of the issues I had is, for example, this cave monster, the charging monster does not actually charge at you or charge at the stone in the cave. And after several hours of testing, I realized that the z-axis actually matters on the detection of the site. I'm not sure the reason behind that, but after I adjusted the the z-axis for the entire level, the monster issue was fixed. I didn't have any similar issues into other levels. Let's say for the the mine level. So yeah, let's see for the mine level, because the entire level is actually not that complicated. It's pretty plain, but there are several walls that can actually block the sights. So I need to make sure that I walk around the entire map, and the two mine monsters and also little spiders can exactly they should be working correctly along with the behavior tree and also the different mechanics. And besides that, I have also added several objects that can be interacted with the players in the different levels. Say there is this lever that needs to be touched in order to reconstruct the rail based on what we had in the story. And after all the 4 rails are reconstructed, you basically created a path to escape out, and there's the final level teleporter gonna be spawning right here. One other interesting mechanic we implemented into the levels is that for the industrial level, we actually have time bomb. So the goal is for the player to escape within 60 seconds away from the behemoth. And then we have this ripple emitter over here, thanks to David, that can actually play sound every 1 second. So like if I turn this thing on, you can hear sound along with actually the timer. So there is the timer on top, and also you need to go along with the sound to find the, well, that's not along with the sound, but you can also hear like the sound goes along with the timer ticking, and you will need to find the escape path and also get away from the behemoth monster within 60 seconds. I assume this is going to be a challenging level because the avoiding monster itself is not hard, but finding a way to get out can actually take some time. So good luck on trying that. And there's also the final level that we implemented our final monster in. We have 2 switches that allows the players to interact, that opens the path for the last door that we need to escape all the way over here. And along the path that we need to dodge, they need to avoid the final boss. Usually they can try to attract the boss and then just quickly goes around and pick up these objects and go in there. But the entire map is going to be blind when it plays like this. The only parts that are going to be lighting up is the places where the 2 objects are. The connection path is completely black out. It's gonna be a little struggle for players to find a way out, so they need to explore as much as possible. And I actually, not gonna lie, I actually scared myself when I was playtesting a level, because the monster just walks towards me the next second, and I wasn't noticing that. I was still looking for a way to go through it, even though I'm the one who actually did this map setup after receiving the level. I'm still kind of struggling on finding the way out, but yeah. So I think this level also is pretty challenging, and that is all the monsters in all the levels. I feel really proud that we actually pulled this one out. I really appreciate the help of my teammates, and that is my part of the game.